untuk kamera.
Oh.
Okay. Saya okey saya.
Okay, sabar. Okay, hello, my name is Shahi. This is a video assignment for mechanics of material, video assignment group 11. So next slide, please. So mechanics of material is study of behavior of solid objects subjected to stress and strain. Usually refer to multiple methods of calculating the stresses and strain in structural members, such as beams, columns, and shafts. Methods used in predict the response of a structure under loading and its susceptibility to various failure modes takes into account the properties of the material, such as its yield strength, ultimate strength, Young's modulus, Poisson's ratio. Next, I'm giving it to Muhammad Nazri.
Hello, my name is Muhammad Nazir bin Nasir, KIB 1900T9, and I will be explaining about LO1, body under action of axial and torsional load. So our real life cases is about the lipstick case. So when a lipstick case, when we want to open the lipstick to put it in our mouth, we have to rotate the base. So the base is torsional, and when the lipstick is going out, it is axial. So the mechanism of the lipstick comprise an inner tubular member, outer tubular member, tubular seat, inner tubular member, rotatable base, two Z shaped slot, rotatable and the rotatable base is fixed coordinately at the bottom of the inner tubular member, so that the inner tubular member will be rotated with the rotatable base. So when the rotatable base is rotated with the outer tubular member, the protuberance will guide along the Z-shaped slot and the spiral groove, and the tubular seat will move in or out of the outer tubular member, thereby controlling the lipstick to go in or out of the outer tubular member. So next slide. So for axial, right now I will explain about axial and the torsional load happen at the lipstick case. So for axial loading, we can define axial loading as applying a force on a structure directly along an axis of the structure. So when we applying a force directly actually towards the beam, the component, it will experience normal stress. Normal stress we can define as an internal resistance that occur at the linear material to an external applied load. So the normal stress is either tensile or compressive stress. So at the lipstick, the tubular seat, the outer tubular and the inner tubular will experience axial loading or normal stress when the lipstick is being put at the lips. So all the component will experience axial loading. Another one, when the protuberance is guided along the Z slot, they will experience normal stress between. Also, normal stress is happen between the lipstick and the tubular seat. So next slide. So for torsional load, torsional load is happen because the action of twisting. We can define torsion is twisting of an object due to an applied torque. So torsional load, uh, torsional load is a load that imparts the turning moment or the torque. By twisting of a body by a force that tend to turn one about a longitudinal axis, while the other end is static or turn in the opposite direction. So the torsional load happen at the lipstick when the base is rotated. they are torqued at the tubular seat and the spiral groove as the lipstick is moving out. When the rotatable base rotate along the outer tubular member, they will also experience torsional stress. For, for if twisting is being experienced by a load, a component, it will deform because they will experience shear stress. Solid round shaft material will experience greater shear stress. We can apply elastic torsion formula to calculate the shear stress in a shaft. For the axial loading, the formula for normal stress is P over A. So our next will be the calculation by next member.
Okay, hi everyone. My name is Chiar Azian, KIB 10026. So from the situation in LO1, we will do a quick calculation on how the lead stick works. So from the situation, we assume that the diameter of the lead stick is 0.03 meter and force acting on the lead stick is 50 Newton. So for first step, we need to find the area of the lead stick with the area formula. So we got the area of the lead stick. After that, we use the normal stress formula P over A to find the stress average. So we get 21.22 kilopascal for the normal stress acting on the lead stick. Okay, so then we need to find the polar moment of inertia or J. So we use the radius of the lead stick. We divide the diameter by 2. We got 0.015 meter. Then for the polar moment of inertia, we just using the formula and we get the J for the calculation. We need to find the J for to use in the torsional calculation. Next. Okay, so imagine that the torsion acting on the lead stick is 9 Pascal. To find the shearing stress, we use the formula T over J multiplied by C. So just insert the amount and we get the shearing stress in 1.698 megapascal. Okay, that's all for the situation 1.
Okay, for the LO2, we want to solve problem involving stress in beams. So the real life example that we choose are a person sitting on a chair. So the weight of the subject is 52 kilogram. The height of the chair is 35 centimeter. The base of the chair leg is 3 times 3 centimeter. So the chair is made of marble wood. So the modulus of elasticity is 15.93 gigapascal GPa. So we assume that all loads are distributed fairly to all legs. So next I'm going to give it to you. So this is the 3D sketch of the legs, and this is the drawing of the legs. The next I pass it to Idris.
Hello, my name is Idris Fahmi, matrix number KIB 10035. So in this situation, we will be calculating the normal stress, the shearing stress, as well as the deformation of each members of the chair legs. So firstly, we are going to calculate the normal stress acting on each legs. Firstly, we have to calculate our area, and then we calculate the average normal stress by using our pressure applied into each legs divided by the total area in meter square. So next we will be calculating the shearing stress. So we derive from the cylindrical shearing stress formula to the rectangular beam. And so from the formula that you can see, the V represent the shear stress, so which is the weight that we apply onto each legs, and then the letter B is representing the weight of the rectangular beams, which is our legs, and then the H will be the height of the chair legs. And lastly, the Y1 will be the geometric centroid if the area was measured from neutral axis. So usually in reference book will be denoted as NA. So from this formula, we will get the rectangular beam shearing stress of each legs will be 141 and 67 Pascal. And then lastly, we are going to calculate the deformation of the leg. So firstly, we are going to need our area of each legs, our total area, and then we need the stress acting on each legs, which is represented by the sigma symbol. And we're also going to use the modulus of elasticity value that were mentioned by Shahir just now. So from the stress formula, we can derive and replace and our so that the sigma will be our subject. And lastly, we can the sigma represent the deformation of the legs, and lastly the L, the capital L, represent the length of the chair legs, just like just now. And so we managed to calculate the deformation of the leg when we apply uh, the force, which is the person sitting on the chair. So that's all for the LO2 or situation 2 calculation. I'll pass to my next team member.
Hello, my name is Muhammad Nazan Hidayatullah bin Shahidi. Matrix number of KIB 190034. So for application in biomedical engineering, so usually materials used in biomedical engineering are usually called biomaterials. They play an essential role in medicine today. So they serve to restore function and facilitating healing for patient after the injury or disease. So biomaterials may be natural or synthetic and are used in medical application to support, enhance, or replace damaged tissue or biological function. The usage of materials in the biomedical engineering field relies upon the mechanics of materials. So the mechanic and chemical properties play an important part to ensure that device created using biomaterials can function optimally, which means that when a certain biomaterials need be chosen to create a device or a prosthetic or an equipment, they must test the strength, the yield strength, bulk modulus, and all the mechanics of material. So that is where the mechanic of material play an important part in biomedical engineering. So as I said, they must be tested through several tests to ensure that the material is suitable to be used for the creation of either device, prosthetic, or even equipment. Okay, for example, the usage of knee implant in a patient with osteoarthritis. So materials used to produce the knee implant must meet certain criteria, such as it is capable to withstand the load of the body, to make sure it is durable, it is biocompatible, and have good mechanical properties, such as it gonna last long, so that the patient doesn't have to change their knee implant. Okay. Lastly, to ensure that the knee implant is able to withstand an applied load without failure and be able to function as a normal knee. So that's is the main function of a knee implant. Okay, lastly for conclusion, so our daily life usually revolve around the mechanics of material. Wherever we go, like when we open the door, the hinge of the door will be there is some strain and stress there, and almost all segment of our life is influenced by materials. We should not underestimate the influence of the material and should focus on improving the quality of materials produced so that the quality of material would be increased in the future. So this would lead to people living a better life with the existence of better material. So that's all. Thank you.